Welcome to 5th Iranian Geometry Olympiad Solution Guide. Here we will discuss about problem 4 of advanced exam. First, we will prove that NK and ML can't be parallel. Look at two triangles AKN and CLM. AC, NL, and KM meet at a common point P. So by Desargues' theorem, the intersection of AK and CL, which is point B, and the intersection of AN and CM, which is point D, and the intersection of NK and ML must be collinear. So NK and ML meet each other on line DB. Similarly, LK and MN meet each other at line CA. And if ML and NK are parallel, then they are parallel to BD2. So we will have KN parallel to BD and parallel to LN. Now, quadrilateral KLMN is a trapezoid which is cyclic also. So KL must be equal to NM. So these two angles must be equal. And so all of these 6 angles must be equal. Now look at ratio TP over KN. It's equal to LT over LK, and it's equal to LP or LN, and it's equal to MS over MN, and it's equal to PS over KN. So TP is equal to PS. Now look at triangle QTS. These two angles are equal, so it's isosceles. And also PS is equal to PT. So QP is median of this triangle. And we know that median of an isosceles triangle is also its altitude. So QP must be perpendicular to BD. So AC is perpendicular to BD. And this is a contradiction, so ML can't be parallel to NK. And similarly, NM can't be parallel to LK. Now because PK and PL are angle bisectors of APB and BPC, we have CL over LB equals to PC over PB. And also KB or KA is equal to PB or PA. Now use Menelau's theorem for points L, K, and Q in triangle BAC. We have AQ over QC times CL over LB times BK over KA must be equal to 1. CL over LB is equal to PC over PB, and BK over KA is equal to PB over PA. So AQ over QC must be AP over PC. And this shows that Q is harmonic conjugate of point P with respect to A and C. And this cross ratio A, C, P, and Q is -1. And similarly, we can show that R and P are harmonic conjugates with respect to B and D. Now look at this picture. Polar of point R with respect to angle LQM is line QP, and so X and R are harmonic conjugates with respect to K and N, and also Y and R are harmonic conjugates with respect to L and M. Now look at the circumcircle of K, L, M, N. Because X and Y are harmonic conjugates of R with respect to these two chords, polar of point R with respect to this circle must pass through X and Y. So polar of R is line QP. And similarly, we can show that polar of Q with respect to this circle is line PR. So because polars of R and Q pass through point P, the polar of point P must pass through Q and R, so is QR. So this circle is polar circle for triangle PQR. Now let K prime, L prime, M prime, and N prime be the points which encircle of quadrilateral ABCD is tangent to its sides. We draw lines L prime K prime and M prime N prime, and name the intersection point by Q. Now we will prove that this point Q is also on line AC and also harmonic conjugate of point P with respect to A and C. We know that polar of point D with respect to this circle is line M prime N prime, and also polar of B is L prime K prime. Polars of B and D pass through point Q. This implies that polar of Q is line BD. So cross ratio BQ, BP, BA, and BC is -1. And also cross ratio DQ, DP, DA, and DC is -1 too. And because these two cross ratios are equal, these points must be collinear. And also A, C, P, and Q must be -1, which proves that point Q and point P are harmonic conjugates with respect to points A and C. Similarly, we can prove that K prime N prime and L prime M prime meet each other on line BD, and at harmonic conjugate of P with respect to points B and D. Now we prove that polar of R with respect to this circle is line PQ, and also polar of Q is line PR. So polar of P must be line QR, and also this circle is polar circle of triangle PQR. So we prove that circumcircle of KLMN is the incircle of quadrilateral ABCD. And because point K and K prime are on this circle and also on side AB, they must be equal. So we prove that K equals to K prime, and similarly we can prove that L equals to L prime, M equals to M prime, and N equals to N prime. Now, look at this picture. We know that this angle is half of the arc MK in this circle. And also this angle is half of the arc KM. So they are equal. And because this angle is this green angle plus this angle, and this angle is this green angle plus this angle, these two angles must be equal too. So the quadrilateral ABCD is cyclic, and we proved our problem. Thank you.